Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 64 minimum path sum. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that you need to go from 0, to n-1, m-1 cell using these two movements, the down and the right one. And when you reach this cell, you have to return the minimum path sum. And what is path sum? If you took something like this path, so sum would be 4, 9, 11 and 12. So 12 is your path sum. So whenever you reach this, you have to return the minimum of all the paths sum. So that much is clear, pretty much easy to understand, no more time waste. So move ahead. Now the main question is how to do it. So one thing to consider is at every cell there is two choices: go down or go right. Go down or go right. You don't know which one leads to the minimum path. You don't know, but you have to take the decision for every cell. So which things strike in your mind when you need to take decision and you don't know, and whenever the result will come, we will take the minimum of it, the right and down. This much is sure, that we have to take the minimum. We know this, but which thing can do this automatically? I think that is recursion. We will make the up call, so not up, sorry, down call and right call, and we'll get the answer. How? We will just have to select the right and down calls, whichever is the minimum, that will be the answer. Recursion will do the hard work. We will just have to, what we have to, just choose the minimum one. So that much is clear what we will be doing. We will doing the recursion. So now for this particular, I have taken started from n-1 to m-1, from n-1 m-1 to 0, 0. You can start from 0, 0 to n-1 m-1. I have taken this route. So in this you have to do up and left, up and left. It is easy to me. This can be easy to you. It depends on you. Just understand this. Same thing goes for this. You can do it. So we are going from n-1 to 0, 0, and we are doing up and left call. So this much is clear. Same thing will happen. Don't worry. Just understand this and you can convert it on your own. Or you can take that as a homework to guess, to see how much you understand the recursion. So how our recursion will look like is, first thing first, our basic call. Let me scroll it a bit. First thing first, our basic call up. When we go up, we have to take whatever is present at that cell. Here it is grid. And what we do when we have to go up, we have to change the row. How are we gonna change the row? Row -1. Simple. Same column. If we have to go left, how to achieve that? Same thing will happen. We'll take that cell value and what we'll do? Same row but column change. This is how we do. And what we do at the end, when this is done, we'll take the min, up and left. So this is clear. But it is something is left, the base case. So one base case is this: when you reach 1, 1, not 1, 1, sorry, 0, 0, would you do the up and the left call? Would you like to do that? No. So what should we do? Just return because that cell should be included in the path. What we will do is return the value of that cell. What we will do is, if something like this row is equal to 0 and column is equal to 0, what we will do is just return whatever is present at 0,0. But still something is left. What if you are at 4 and you do the left call? Is it right? No. On 3 you do the up call. Is it required? No. So see, you are taking min, and we are taking, let's take the example of 4. On 4 you cannot take the left call, you have to neglect the left, so you are taking min. What should come in your mind is, make this max something big value. You will then always take the up. That's very basic. Make this max, you will automatically take the up. Or if you don't require that on 3, you don't require that up call, make up as something big value, you will automatically take left only. So this much is clear. So what we will do, if row is less than 0 or column is less than 0, return 1e9. This is the value that I took. You can took whatever you like after seeing the constraint. So the time complexity of this solution is, why 2 power m into n? Because for every cell we have 2 choices, the up and the left. So this is it, and space would be something like this: O of m-1 and n-1, the recursion space, the recursion stack space. How that came is, when you start from here, this will be inside the recursion stack, this will not, because we will just return from it. How many cells we did? 4 cell, or we can say the path length. This is also can be said as path length. So how you get the path length? m-1 n-1, pretty much easy, but it will not be accepted for this, not accepted TLE. So what we can do is memorize it. Why we memorize it? Because if something is computed in past, so why walk that path again? Just use the result. There are many different states according to it, but there are only m cross n cells. There are only m cross n things. If we store that, we will save that calls. So how we store that? We declare a vector, 2d dp, oh sorry, 2d vector, and what we do, we'll declare it same as this grid given, and we will put -1 over here. Why -1? -1 shows that state is empty, nothing is there, it is not visited, something like visited. So this much is clear. What will this give us is time complexity O of m cross n, because there are only this many new states, but space will be still something to be of concern. And this is the memoization dp. This is our memoization dp, but this will be accepted. You can eliminate this also using tabulation, but explaining that tabulation will make this video much longer. So for this time being, we'll do till memoization. Let's see the code. This basic thing, n and m. This is as discussed, the base case, as discussed, the invalid move. And if it is stored, if it is already visited in the past, why recompute again? Just give the answer back. And that are calls up and left. You can do down and right. It depends on you. It feels more easy for me. In other question, it is sometimes better. And also from this, it is easy to convert into tabulation. But I am not discussing it right now because video will get lengthy one. There are videos for this using tabulation. You can watch them. So this much is done. This is how we are doing. We take the minimum of both of them and store it inside for our next visit. If it is visited, we will just return it. So that is pretty much easy. That's how dynamic programming or memoization work. And this is where we declared our memo, the DP, and we'll just return it as how the recursion works. Yeah, it is submitting. And if you wonder why I am not doing the dry run will also make up this video very long, and you should do dry run on your own because it will be quite long one. We have to make full tree over it, many calls. So I'm not going into that part. I'm just giving you the problem solving mindset or the way, or just a candle make your whatever. So if you like this video, if you did learn something, so consider subscribing to the channel, and you have to do what you have to do. So keep grinding. See you in the next one. Bye bye.